Okay, so we're in section 2.7 of Al Grosch's book, Developmental Math 2. We're going to do some problem solving. So problem solving is just a fancy term for word problems, which I'm sure you guys already know, but here's some strategy that you can kind of familiar yourself with here in the first 5 steps. Analyze the problem, possibly draw a picture. Drawing a picture is always helpful to me. Form an equation is the next step. Solve the equation, state the conclusion, and check the result. It seems like these 3 steps at the bottom, solving the equation, stating the result, and checking the results, are the easier part. It's actually forming the equation that students seem to have the most difficulty with. So we're going to have to focus on that. Sometimes you have to read the problem a few times, 3 times, 4 times, 5 times even, to understand exactly what information is there, what information you're looking for, how it all relates together to form an equation. So you can look at the first example here. A CD is priced at $15 but is on sale for 20% off. What is the sale price of the CD? To analyze the problem, we're going to decide what information we already have. We already have an original price, $15. We know there's a discount. What is unknown is the sale price. So form an equation. Well, how do we know how these things relate together? And this is one of the formulas we had. The original price minus the discount equals the sale price. The original price is $15. The discount is 20%, but it's 20% of something. Percent is always of something. So it's 20% of the original price. So you're going to have to follow order of operations here. Multiply the 20%. That gives you 3. 0.2 times 15 is 3. Subtract that from the 15. State the conclusion. The sale price of a CD that was $15 discounted at 20% is $12. It's always a good idea to state your conclusion to a word problem in a complete sentence. And then, of course, check the result by going back to your original equation, putting the variable in there, and making sure that it checks out. All right, so on this page, we've got some word problems we're going to work on. A pair of jeans is priced at $50 but is on sale for 25% off. What is the sale price of the pair of jeans? All right, now the first 3 questions on this page are all about sale price and discounts, percent increases, all stuff like that, having to do with original cost and a discounted or increased cost. I'm going to give you a formula that I like to use. It works for all 3 of these types of questions. It's just you have different unknowns. So let's enlarge this a little bit. The formula that I like to use says the original times whatever percent you're paying, and that's not the percent off, that's the percent that's left after you take it off, equals the new price. So we're going to try it with this first question. The original price is $500. All right, what percent are we paying? And this is where some mental math can come in. If it's on sale for 25% off, then you can take 25% off of the entire whole, which is 100%. So when you take 25% off, you're paying 75% because that's what's left after the 25% comes off. So we're really paying 75%. So this would be times 75%, of course, in a decimal. We always change percents to decimal, 0.75, and that will equal the new price. So 500 times 0.75 will tell us what the new price is. So all you have to do here is the actual multiplication, which you can do off to the side. 0.75 times 500 equals, you can just drop these zeros down. 5 times 5 is 25, 37. Don't forget to count your decimals, 1, 2. See, there's 2 decimal places, so we're going to go into here, and we're going to put the decimal in here. So we have 375 equals the new. And of course, that's dollars. All right, and number 2, if a television cost $311 after a 35% discount. What was the original cost? I'm going to use this same formula. The original times whatever percent I'm paying equals the new. Do I know the original cost? I know the television cost $311 after the discount, so that's not the original, that's actually the new. So we could put $311 over here as the new price. I don't know the original, so I'm going to label that as X. That's what I'm looking for. It says, what was the original cost? All right, what percent are we paying? If it's a 35% discount, 100% take off 35%. Leaves you with 65%. So in a decimal, 0.65. So how do we figure out what X is here? This is an equation. So to isolate this X, we have to undo this multiplication with division. So we need to do some divide by 0.65. Don't be scared because it's division by decimal. You just have to practice it a little bit. We can go over here to the side. What are we dividing? 311 divided by 0.65. Okay, you can divide that out. It ends up coming out as 478.46 rounded to the nearest cent. All right, let's try number 3. If a DVD player cost $306 after a 30% increase in price, what was the original cost? I'm going to start with the same formula. The original times whatever percent you're paying equals the new. Okay, what do we know? If a DVD player costs $306 after the price increase, so that's the new price, the $306. Okay, this is an increase in price, not a discount. It's a 30% increase in price. So again, starting at 100%, if we increase it 30%, this time we're paying 130%, which in a decimal is 1.3. We don't know the original, so that's the variable. Again, to get rid of this, to isolate this variable, we have to divide off the 1.3. So you have 306 divided by 1.3, which you can do over here to the side. And that comes out to be 235 and 38 rounded to the nearest cent. And that makes sense. Since this was an increase in price, the original cost should be lower to make room for the increase to 306. All right, the next question is simple interest. And here's the formula for you. Now you're going to want to memorize this formula because it is on the midterm and the final exam. Interest equals principal times rate times time. The principal is always the large amount that you're investing or you're taking a loan on, you're borrowing. The rate is always the percent number, and that sometimes is a little confusing to people. And the time is always in years. So the interest and the principal are both dollar amounts, while the rate is a percent. Okay, so if we start with this formula, interest equals principal times rate times time. I guess we should read the question. Find the amount of money necessary to be invested now at 5% simple interest to yield $200 accumulated in 8 years. The tricky part about these questions is where do all the numbers go in this formula? So let's look. Find the amount of money necessary to be invested now at 5% simple. Okay, this is the rate, the percent number, so I'm going to put that in place of the R. And again, in a decimal, 5%. Okay, 5% simple interest to yield $200 accumulated in 8 years. Okay, if you're yielding $200, then that is the interest amount. You're looking for the amount invested, so you're looking for the principal. You know the interest is going to be $200, and the time is 8 years. So that's how this turns out. And again, we're down to one variable here. We're going to solve for p. So we need to simplify 0.05 times 8. We have 200 here. 0.05 times 8 is 0.4, and we still have our p over here. Now I just changed the order, but since it's multiplication, it doesn't matter. This is the coefficient, so it goes in the front, and the p turned to the back. But since it's all multiplied, it doesn't matter what order you write it in. This is just a standard way to write algebra. And then, of course, divide by 0.4 to find out what p is. 200 divided by 0.4, you can do, again, as long division. You end up with 500. And that makes sense. You invest $500, you get $200 in interest. All right, on this page, we're going to do a little bit of geometry here. So again, we've talked about some of these formulas in the formula section. So you're going to want to memorize these. You're going to see them again on your midterm and your final. The length of a rectangular garden is 8 meters more than its width. Its perimeter is 76 meters. Find the length of the garden. Okay, we're talking about a rectangle here. So this is where a picture is helpful. Rectangles have length and width, and I always use L and W so that I know which dimension I'm talking about instead of X and Y or something generic like that. Use length and width. The length of a rectangular garden is 8 meters more than its width. Okay, you need to take this and finish your description of the length using this description up here. 8 meters more than the width is 8 more than width, or length equals 8 plus width. More than means plus. All right, the perimeter is 76 meters. Find the length of the garden. Okay, since we're talking about perimeter, we're going to need that formula for perimeter of a rectangle, which is P equals 2L plus 2W. 2 times the length plus 2 times the width. And then we're going to fit the numbers in here. Since the perimeter is 76, yes. Since the perimeter is 76, we can put a 76 here. Since the length was 8 plus W, we can put that here instead of length. So we're going to have 2 times 8 plus W plus this 2W that's down here at the end. We're going to simplify and solve. So using distributive property here to get rid of the parentheses, we have 76 equals 16 plus 2W plus this 2W here on the end. Okay, we have like terms here, the 2W's. So 76 equals 4W plus 16. All right, solving for W, we have to subtract the 16, and then we're going to divide by 4. So subtracting the 16 from both sides gives you 60 equals 4W. And then when you divide both sides by 4, you have 60 divided by 4 equals 4W divided by 4, or 15 equals W. However, when you look at the question, it says, find the length of the garden. We just solved for width. That doesn't mean you made a mistake. That means that's how the question all lined up to solve for width. That's not the answer to the question, though. The question says find the length. So how do we take what we know now? We put it back in here. The length is 8 plus the width. If the width is 15, the length will be 8 plus 15, or 23. So the length of the garden is 23 meters. All right, on the next question. The perimeter of a triangle is 30 inches. The length of the middle side is 2 inches more than the length of the smaller side, and the largest side is 4 inches more than twice the length of the smallest side. Whew! Find the length of the small side. All right, we're talking about a triangle here. And obviously it has 3 different sides, 3 different length sides. So we can label them as the smallest side, the medium side, and the larger side. And now you have to look at the information. The perimeter of the triangle is 30 inches. So I'm going to put that in the middle. The perimeter is 30. The length of the middle side is 2 inches more than the length of the smaller side. The length of the middle side, that's here, the length of the middle side is 2 inches more than the length of the smaller side, and that's an S, not a 5. What else do we know? The largest side, so that's up here, is 4 inches more than twice the length of the small side. So again, the largest side is 4 inches more than twice is times 2, the length of the smaller side. So we have some equations, some expressions here to help us out. All right, what do we know about the perimeter of a triangle? Do we know a formula? Turns out the perimeter of a triangle is just the smallest side plus the middle side plus the longest side. So if we add up all the sides, it will equal the perimeter, which is 30. We don't know anything about this smallest side right here, so that one stays as S. We do know that the middle side is 2 plus S. So instead of writing M, we're going to write 2 plus S. And instead of writing L here, we're going to write 4 plus 2S, if we have enough room. Be careful to write your S's like S's and not like 5s. So 30 equals S plus 2 plus S plus 4 plus 2S. And we got all of those from this information right here. So now we need to combine like terms. So we're going to leave 30. Okay, we have one S, another S, and 2S. And those are all like terms. When I add them up, I get 4S. And this 2 and this 4 are like terms, so I get 4S plus 6. Okay, so 30. Let's go ahead and start solving now. We need to subtract 6 from both sides. So we're going to have 24 equals 4S. And then when you divide both sides by 4, you end up with S equals 6. Does that answer the question? Find the length of the small side. Well, since the small side was represented by S, then yes, that does answer the question. S equals 6 inches. Let's put some inches on there. All right, the next question. If 8 times a number is increased by 20, the result is 26 less than the square of the number. Translate the statement where the number is represented by X. Okay, we don't have to solve this. It just says to translate, so we're just writing an equation. So if 8 times a number, well, the number is X, so 8 times a number is 8X. Is increased by 20. Increased means add, so that's plus 20. The result is means equals. 26 less than something does not mean you're starting with 26. It means you're going to take 26 away from something. So I'm going to leave a space, and I'm going to take the 26 away. 26 less than what? What does it say? 26 less than the square of the number. How do we write the square of the number? Square is a way to say the exponent 2. So this is an exponent of 2 on the number, which was X. So this is X squared, or the square of the number. 8 times a number increased by 20 is equal or results in the square of the number minus 26, or 26 less than the square of the number. Create a proportion that solves this problem. A car can travel 603 miles for 11 gallons of gasoline. How far can the car travel for 36 gallons? Okay, so we're comparing miles with gallons here. So we're going to set up a couple of fractions with miles and gallons. All right, a car can travel 603 miles for 11 gallons. So 603 miles for 11 gallons. How far can the car travel for 36 gallons? So the 36 gallons needs to go here on the bottom. And we're looking for miles. And if you remember the lecture about proportions, we can use the cross products to create an equation. So 11 times x will equal 603 times 36. So 11x equals, when you multiply 603 times 36, you get 21,708. So of course, to isolate this x here, we have to divide by 11. So if you do that division off to the side somewhere, you should get x equals 1,973.45 rounded to the nearest hundred there. And that's a rounded answer. Well, so if you're doing the division, you know, it's not going to come out perfect. I rounded it to the 2 decimals. All right, the last question is probably the most challenging one. 2 cars start from the same point and travel in opposite directions. The rate of the slower car is 15 miles per hour less than the rate of the faster car. After 8 hours, they are 840 miles apart. Find the speed of the cars. We're going to start with a picture. The 2 cars are starting in the same place and they're going in opposite directions. Okay? So we have 2 different situations going on here where we have a slower car, and I'm going to call that D1, and a faster car, and that D stands for distance. The second car is D2. All right, the formula is distance equals rate times time. Okay? So that's what you're going to need to know here. Okay, the rate of the slower car is 15 miles per hour less than the rate of the faster car. So each car has its own rate. We're going to call this rate 1, and we're going to call this one rate 2. It says the rate of the slower car, it doesn't matter which one, let's just call 1 the slower, is 15 miles per hour less than the rate of the faster car. So I can put that information here just like I did with the triangle or the rectangle. This one is 15 miles per hour less than the other one. So it's rate 2 minus 15. After 8 hours, so the time for both of them is 8. Time 1 is 8, and time 2 is 8. They are 840 miles apart. Now you're going to be wondering, where does that 840 fit in? But if you think about it, they're going in opposite directions, just like the picture we drew. One of them is going this way, one of them is going that way. That means that at the end of their time, they are 840 miles apart. So all of this is going to equal 840. So what that means, that if I add distance 1 plus distance 2, it's going to equal 840 miles if I add up those 2 distances. So that's where I'm going to actually start. I'm going to start with distance 1 plus distance 2 equals 840 miles. And then I'm going to start substituting rate and time in there, because we know that distance equals rate times time. Instead of saying distance 1, I can say rate times time, because that equals distance. Rate 1 times time 1 is the same as distance 1 because they're equal. And then I can say rate 2 times time 2, because that's the same as distance 2, equals 840. And now I can put some numbers in. I know both of the times were 8. So I can replace time 1 and time 2 with 8. I also know that rate 1 equals rate 2 minus 15. I don't know anything about rate 2, so rate 2 is actually the one that has to stay in. But rate 1 is the same as rate 2, 15. Trying to write this neatly, but I'm having a hard time. Rate 2 minus 15. That's bad. I can't erase that. Rate 2 minus 15. All right, so what I have here, I have some white space maybe. Let's rewrite it. Rate 2 minus 15 times time, which is 8, plus rate 2 times 8 equals 840. So I'm going to start simplifying. I'm going to start here with the parentheses. 8 times rate 2, R2, minus 8 times 15 is 120, plus, I'm just going to reverse this order, 8 times rate 2 equals 840. All right, looks like we have some like terms here. 8 rate 2 and 8 rate 2 makes 16 rate 2 minus 120, there's the 120 right there, equals 840. All right, so we're going to add 120 to both sides. So you have 16 rate 2 equals 960. And then you're going to divide by 16, and you get rate 2 equals 60. Now, if we look at the question again, I know I'm going to have to cover some of this up to scroll this question down. It says find the speed of the cars. So I'm looking for the speed of both cars. This was just the speed of the second car. The speed of the first car is right here. Rate 1 equals rate 2 minus 15. So if I know rate 2, I can find rate 1 equals 60 minus 15, or 45. So one of the cars is going 45 and the other one's going 60 miles per hour.